Have you ever wondered if a machine could listen and understand speech better than a person? Well, it's not science fiction. Today we're going to unpack a groundbreaking paper that made this a reality. And honestly, it changed how we talk to our devices forever. I mean, just think about that for a second. An AI that could listen to someone talk and just write it all down, with fewer mistakes than a professional human who does this for a living. It sounds like something straight out of a movie, right? Well, it's real. That's exactly what a team of researchers did back in 2015. They built a system that could pull it off, and they called it Deep Speech 2. And look, this thing was a massive leap forward. We're not talking about a small improvement here. This was a total game changer. It was so powerful that the same exact AI design could understand two completely different languages, English and Mandarin. Now, to really get just how big of a deal this was, we got to take a quick look at how speech recognition used to be done. And trust me, it was a completely different, way more complicated world. So on the left, you've got the old way. Think of it like a clunky, old-school assembly line. It had all these separate, hand-built parts that experts had to tune just right. It was super brittle. If one little piece broke, the whole thing fell apart. Deep Speech 2, on the right, just threw all that out the window. It's more like one single giant brain that learns the entire job all by itself. We call this an end-to-end system, and this idea was a revolution for AI. I mean, just look at this. This was the old way. You needed one part for audio features, then an acoustic model, then a pronunciation model, a language model. Each one of those steps was a huge field of research on its own. It was just a nightmare to build and maintain. And then there's the new way. All that complexity, gone. You just feed audio in one end and you get clean text out the other. The neural network just figures everything else out on its own. So simple, so elegant, and crazy powerful. So the million-dollar question is, how on earth did they do it? How do you build one AI brain that can do the work of that whole complicated assembly line? Well, it really boils down to three secret ingredients. So let's talk about ingredient number one. If you're going to build a smarter brain, well, you need a better blueprint for it. And their blueprint was pretty straightforward. Just go deeper. They built a much deeper AI model. Instead of just a few layers, they stacked up to 11 of them. You can think of it like adding more and more layers of thought, which lets the AI pick up on way more complex and subtle patterns in the way we talk. But, a really powerful brain is totally useless if it hasn't learned anything. And that brings us right to ingredient number two, the data. They gave this AI a giant library to learn from. This isn't like learning from a small textbook. This was total immersion. The AI listened to a crazy variety of voices, all kinds of accents, and even speech from noisy places. This is what made it so tough and reliable. And when I say a giant library, I'm not kidding. For just the English model, they used almost 12,000 hours of speech. To put that in perspective, that's like putting on headphones and listening to someone talk 24/7 for over a year and a half straight. That's a lot of data. Okay, so you've got a deep brain and a massive library of data to teach it with. But there's one huge problem. How do you actually process all of that information? That brings us to our final and absolutely crucial ingredient. You need some serious horsepower. Trying to train a model this big on that much data with a normal computer would take forever. So the team used what's called high-performance computing. They basically linked together a whole bunch of powerful GPUs, yep, the same kind of chips that run your video games, to create an absolute beast of a computer. And what did all that computing power get them? A 7-time speed up over their old system. Now here's the key takeaway. This meant that experiments that used to take weeks could now be done in just a few days. This let them try new ideas, fail fast, and find the perfect AI design way, way quicker. All right, the moment of truth. They built it, it's got a deep brain, it's learned from tons of data, and it was trained on supercomputers. But the real question is, how well does it actually work? It's time to put it head-to-head with its ultimate rival, a human being. So let's look at the results. This chart shows something called word error rate. Basically, lower is better. On this test with really clean, easy-to-hear speech, you can see Deep Speech 2 is right there, neck and neck with a professional human transcriber. In fact, it's actually a little bit better. But this is where things get really wild. On some other standard tests, the results were even crazier. On these tests, the AI didn't just keep up with humans, it blew right past them, making significantly fewer mistakes. This was a huge, huge moment. But okay, let's be real, the system wasn't perfect. When they threw it a curveball and tested it in really noisy places, like a crowded coffee shop or a busy street, humans still came out on top. Turns out our brains are still the undisputed champions of filtering out background noise, which is a really hard problem for AI. So we've got an AI that's basically a world-class transcriptionist, at least when it's in the lab. But there is one last massive hurdle to clear before you can put something like this in a real product, like the voice assistant on your phone. And that challenge is all about speed. Being accurate is great, but if you ask your phone a question and have to wait 10 seconds for it to figure out what you said, well, the feature is totally useless. The AI had to be not just accurate, but lightning fast. And they absolutely nailed it. They used some really clever engineering tricks to process a bunch of requests at once. And they got the response time down to just 67 milliseconds. That is literally faster than the blink of an eye, and more than fast enough for a perfectly smooth, real-time conversation. You see, Deep Speech 2 was way more than just a cool speech recognition system. It was proof of a philosophy, this end-to-end learning idea. It showed the world that if you have enough data, enough computing power, and the right kind of AI brain, you can teach a machine a complex human skill from scratch. And that leaves us with a pretty mind-blowing question. If an AI can truly master listening, what's it going to learn to do next?